Perfect. You are using 1 and 3 in order to find the order with respect to B, because for 1 and 3, concentration of A is constant, and then you can concentration for A. Okay, it stopped sharing, so let me do it again one more time. Okay. Concentration for A is constant, so when you divide the rate 3 over rate 1, the value for A is going to be whatever it is going to cancel. K would cancel, and then you could find the ratio concentration of the B changing and rate changing. When you double the concentration of B, what happens to the rate? Trial 1 and 3. The rate is quadrupled. So when you double the concentration and the rate is quadrupled, the order is going to be 2. So you have a second order with respect to B, first order with respect to A. Perfect. So we are using both definition and both formulas for calculating our rate today. We are using the change in concentration over change in time, and we are using also this equation to find the order for the reaction. So the way this experiment is designed, I'm not saying this is going to happen all the time, but the way this experiment is designed, when you see the color change, okay, when you see the color change, you are using equation number 19 to calculate the rate. So for all trials, trial 1 to 7, the rate would equal to 6.30 times 10 to negative 4 divided by delta T. So if for trial 1, the time for color change, or the average time for color change, is 30 seconds, you divide this number by 30, and that gives the rate for trial 1. So you can calculate the rate just by finding the time for color change. Is that clear? Was that clear to you before? Okay, so I just want to make sure.
Can you please repeat that?
Sure. So if you look at page 40, equation number 19, the equation here, it says rate equals, at the end, okay, use just this last part, okay, just this last part, 6.30 times 10 to negative 4 divided by delta T. So on the report sheet or data sheet, first of all, when you watch the video, you are going to find the time for trial 1, you find the time for trial 2, and so on. And so on. So when you have the time, you can find the rate for that trial. How do you find the rate? You use equation number 19 to find the rate for each trial. Then, since you are doing like 2 trials, at least, for each step, or using the table, you're doing 3 trials, you're using equation 20 to find the order with respect to one of the reactants at the time. Okay? So you are going to find the value for X, you are going to find the value for Y using different different steps. So let me go to either the procedure or this table, then it makes probably more sense to you. So for trial 1, what are you doing in trial 1? I'm sure you have read the experiment. What are you doing in trial 1? You are going to add the content of flask A1 to flask B1, right? So you are adding the A1 plus B1. And you wait for the color change. So what you have in the A1 and what you have in a B1, you are going to mix the two, and you look for the color change. Concentration of the iodine. You can see the screen again? Okay. I'm glad that you told me, because this has happened in the past. Please, every time the screen goes away, please. I don't know, has to do with the Wi-Fi or the program is. Okay, so when you add the A1 to B1, instead of saying or explaining in this procedure, okay, that take flask 1, add 1 milliliter of this, 2 milliliter of the other one, and 8 milliliter of the last one, instead of all of this, what is saying, follow this table and add the solutions to flask A1, add the solutions to flask B1. For flask 1, you are adding 1 milliliter of starch, 2 milliliters of the S2O3, 8 milliliters of iodide, and 0 milliliters of nitric acid. That's for your flask 1, A1. Flask B1, you're adding 4 milliliters of S2O8 and 4 milliliters of ammonium sulfate. Okay, so when you mix A1 and B1, the reaction is going to take place. The reaction that is taking place is between iodine and iodine and S2O8, right? So let me go to the data sheet. I'm going to show you exactly what you need to do. So your trial number, which is 1 for trial 1, you're adding A1 plus B1. Trial 2, you're adding A2 plus B2. What is A1 and A2? Those are the flask, and the tables shows you which liquids goes to A1 and which liquids go to B1. And the next step is asking you to calculate concentration of iodide after mixing. What are you using to do the calculation? Unfortunately, my surface is not working. So what I'm going to do, I'm going to use a piece of paper to show you the sample calculation. This is just a sample calculation, okay? And let me see, make sure that you see the, oh, my video went off. Okay, can you see the paper? Okay, I'm going to find the concentration of iodine for trial 1 only. For trial 1 for now. Concentration of iodine, the table I know because is it said that the internet somehow today, the day that I really need it. Okay, the concentration for iodide is calculated based on dilution. Okay, it's based on dilution. Hold on, let me bring a marker. Maybe the marker would be easier. Okay, so concentration for iodide ion. Don't worry, we won't move around until you can see it. So make sure that you can see it. Okay? So concentration for iodine, we are using M1 V1 equals M2 V2. You all know this formula already, so it's not like a new discovery, M1V1 equals M2V2. So if it says find the concentration for iodide after mixing, it's just saying when you change the volume, what would be the new concentration for iodide? What was the M1? Can you look at table 2 and tell me what is the concentration? And then the other one, let me just write here and then I get back to you. Let me, I would make sure that is going to show you, don't worry. Concentration for S2O8, 2 minus. Okay, we go to table where we had the A1 and B1. Okay, from the table, can you tell me what is the M1 for iodide? From the table, tell me what's the M1 for iodide, because I need to replace that in this formula. What's M1 for iodide? Use the table and tell me. I don't want to give you the number, so you can find it yourself. What's M1 value? Use table row A1. Can you hear me? Are you looking for the value M1 for iodide? No. A1, no. M1 is not 1. How many milliliters iodide are you using? How many milliliters of Ki, potassium iodide, are you using? That would be on table 2-2. You are using 8 milliliters. The table is called 2-2. So 8 milliliter, that is 8 milliliter, that is the V1 for iodide. I'm looking for M1 for iodide. What is the M1 for iodide? Just look at the header for that table. It says volume of 0.2 molar. Perfect. Thank you. Okay. So you have the 0.2 times 8 milliliter. Okay. 0.2 times 8 milliliter. So this is a 0.2 capital M and this is a milliliter equals M2 is unknown because that's what we are trying to find. We are trying to find the shoot. Okay. We are trying to find the M2 concentration after mixing. Can you tell me what is the V2? What is V2 for iodine? V2 for iodine. This is after mixing A1 plus B1. We are mixing A1 plus B1 for this trial. What would be V2? I know it's 19, but I want you to find out where that 19 is coming from. Okay, that's how we calculate the concentration for iodide using M1V1 equals M2V2. M1 is given in that table. The header for the table is a 0.2. V1 is telling you use 8 milliliters. And the M2 is unknown. That's what we're trying to find out. The V2 is volume after mixing. Add these numbers that I'm telling you. 1 milliliter of starch, 2 milliliters of S2O3, 8 milliliters of Ki, 4 milliliters of S2O8, and 4 milliliters of NH42SO4. You see where that 19 is coming from? 19 is coming from 1 plus 2 plus 8 plus 4 plus 4. This is the 19 milliliters. Simple formula. The only challenge is finding 19 milliliters. Did you find out? I want you to look at the table and find that 19 for yourself. Add the volume from A1 flask and volume from B1 flask. And please take a screenshot of this right now because I want you to have it. Simple calculation. It's not a huge, it's a big deal. Just maximize the camera and take a screenshot of this. You got it? Okay. Perfect. So you find that value for M2, which is 0.2 times 8 divided by 19, whatever that number is. Now, it tells you to find the concentration for S2O8 2 minus. S2O8 2 minus, what is the M1? I'm going to use the same formula, M1V1 equals M2 V2. What is the M1 for S2O8? Use the table 2-3. Perfect. Thank you. So you are all getting it. So I want to, not that I want to challenge you, but I want to make sure you can read that. What's the volume?
V1? Hold on. Where are you getting the 0.2? I'm looking at the same table and I don't see a 0.2.
Okay. Look at the table that is called 2-3.
Says preparing solutions B for A. Yeah, got that.
Okay. So B1, in that gray area or the table header.
Sorry. Thank you.
That's fine. That's fine. I'm glad that someone asked because I want to make sure everyone could see it because we are using tables like a picture instead of writing many paragraphs. Okay. But you can find the information there in the table is provided in the table. And that's why I do this practice with you to make sure that you can find the information. Okay. So what is the V1 for S2O8? Formula. Do you all see that is 4 milliliters for before mixing? Is there anyone who cannot find information, either the 0.2 or the 4 milliliters for V1 for the 4 milliliters? Okay, what's the value for M2? Do we have a value for M2? That's what we are trying to find, right? So that's our unknown. So what is M2? What would be the V2 value for V2? This is for the trial one also. Is 19. So what you're adding A1 plus B1. The way this experiment is designed, for all after mixing volume, it adds up to 19 milliliters. But that 19 milliliters is not the magic number. We're just adding numbers. Adding the volume from flask A to flask B for each trial, and you find the final volume. Where do we get the initial volume? From the table, directly from the table. Concentration before mixing, directly from the table. Concentration after mixing is unknown, and we need to find it. Now, for trial 2, what does it change for iodine? If you're trying to find the concentration for iodine, what does it change on this page? Using the table, tell me what does it change? Does the M1 change? No? Okay. 8 milliliters changes to what? 8 milliliter changes to? For trial 2, 8 milliliter changes to 4 milliliter. And the final volume is going to be? After mixing, V2, value for V2? No. Maybe you forgot to add the 4 milliliters coming from? No. For trial 2, remember, for trial 2, you are adding A2 plus B2. For trial 2, you're adding A2 plus B2. What do you have in A2? 1 plus 2 plus 4 plus 4. And for B2, you have 4 plus 4. Okay, please do your math one more time. It's a simple math. Go across A2, add all those numbers together. And then go across B2 and add the numbers. How many of you found 19? Did anyone find different number? When you are adding A2 plus B2, you should find 19. And if you find 19, you're fine. Okay? So that's how you use your table for calculation of each of the reactant after mixing. Please take a screenshot of this. This is for trial 1 only. Take a screenshot of this. This is for trial 1. And you do the same for all trials, knowing that for trial 1, we add A1 plus B1. For trial 2, we are adding A2 plus B2. Perfect. Okay. So, what we are trying to do here, we are trying to, like between A1 and A2, we keep the concentration of S2O8 the same, right? We keep the concentration for S2O8 or the volume for S2O8, the quantity for S2O8 the same, but we are changing Ki. We are using 8 milliliters and 4 milliliters, so the concentration is going to change. Concentration is doubled for A1 or trial 1. Concentration for Ki is half on the trial 2. And then you can divide the A1 by trial 1 by trial 2. So the rate for trial 1 divide by rate over trial 2, and that would, from that you can find the value for X, which is for iodine. For iodine. Now, in order to find the value for S2O8, you have to keep the concentration for Ki the same. And that's you are doing that in practice. You keep the concentration for Ki the same, but you are changing concentration of S2O8. So you keep this concentration for Ki the same. You are changing concentration for S2O8. When you are dividing, it's always better to divide the greater rate over the smaller rate. So if the trial 4 has greater rate, divide 4 over 3 instead of 3 over 4. This is just calculation. It doesn't mean that you cannot do 3 over 4 and find the answer, but it makes it easier when you get the number that is not fraction at the end. How do you find, can you tell me how you find the rate for each trial? How do you find the rate for each trial? When you do experiment, how do you find the rate for each trial? Remember equation number, it was equation number 19, right? On page 40. Equation number 19. Okay. How do you find the rate for each trial? You are going to say 6.30 times 10 to negative 4 divided by delta T. What is delta T? Delta T is time to see the color change. When I am performing that experiment, I usually write the numbers for each trial on the chat area. Do you know how to open and close the chat box when you are watching the video? Just like here, as we are, Okay. So you're going to just, is a gray arrow on the bottom right side. There's a double arrow. You click on it, you open the chat. Okay. So it's the same thing. When you're watching the video, you will see that gray, the double, purple double arrow sign at the bottom right side. When you expand it, you will see the chat that was recorded. Like the chat area shows a lot of information for you. Okay, let me ask if you have any questions. Do you have any questions? So I'm going to go over data sheet just to go over, just to make sure that you all know what to or how to do the calculation. Even though this is covered in lecture, but in the lab is actually you are collecting data and you are performing calculation based on the data that you collected. So it's going to make more sense after you're done with the lab. And before that is going to be challenging for you, but I'm trying to just make it clear so you don't have to go through, you don't have to learn it in a hard way. So what you do here, you have to show your calculation. First of all, this area is to show your calculation. What are you trying to show here? Copy the screenshot, the first screenshot, which is the concentration of iodide for trial 1. Okay, for trial 1. And then concentration for iodide for trial 2. You have to show it here also. Then you find the concentration for S2O8, trial 1 and trial 2. So these headings are shared. So basically is 1 and you are sharing the A1 plus B1 and you find the concentration. This area would be the second screenshot that I showed you. You find the concentration for this and show your calculation also. The time until the color change, you see this in the video. So when you watch the video, you record the time for trial 1 and you record the time for trial 2. Reaction rate. How do you find this number? Reaction rate. How do you find that number? If you have the time here, which is delta T, you would use equation number 19 to calculate the rate. Let me see what's the question. Yes, you have to show your calculation. You put your calculation in the blank area. Yes. And since it's Word document, it will expand, so you're not limited in the space. How do you find the rate, reaction rate? First, you record the time from the video, then you use equation number 19, that would be 6.30 times 10 to negative 4, divide by this value that you find from the experiment as a delta T, as the time for the reaction. Okay? Order of the reaction, when you are done with trial 1 and 2, you can find the order for reaction for iodide. Typing out using equation editor, that would be the most acceptable way. Use equation editor and use the and since it's a Word document, that's one of the reasons I made it a Word document. On the keyboard, you have the brackets. The brackets that shows the when you are using brackets, it shows the concentration. So you basically, you're using bracket, and then you would say iodine, and then negative charge, and then bracket. So that's the concentration of iodine. So use do not insert too many images, because that's going to make the file size greater and it's not professional. Use equation editor in Word document and type in your calculation. And when you type in calculation for the, I'm glad that you asked, but when you type in the calculation for one set, you can copy and paste for the next ones because you're only changing one number. That is the most, a manageable way and is a shortcut. But spend the time, use the equation editor, and carefully type in the calculation for one trial at least. Okay. Any other questions you might have? So you would do the calculation for the iodine, and then these are exact same calculation as you had in the other one, except the volume of iodide is going to change. The final volume is going to be 19. For trial 3 and 4, volume of iodide is going to might be different, or if it stays the same, then it's the same calculation. And for S2O8, if the volume of the S2O8 changes, for B3 and B4, and you would find the concentration here. Same thing, you find the volume, time for color change from the video, specifically chat area, because I tried to write these down when I was doing the experiment. And then use equation 19 to find the rate for trial 3 and to find the rate for trial 4. And show your calculation for the order of the reaction. So when you have the order with respect to iodine, order with respect to S2O8, then you could say the rate law. Rate equals K, concentration of iodine to, let's say, 1, and concentration of S2O8 to 1, but you have to show your calculation that they are actually both 1. And I think both of them are 1. For the trial 5, 6, and 7, you have different temperature, so all the calculation is going to be the same. So it's just one. The concentration does not change. The only thing that is changing is the time, and the time is different here. Rate is going to be different for 5, 6, and 7. You have 3 different rates, and since you already have the value for X and Y now, and you have the value for rate, you can now calculate the value for K for each trial. And then you find the L and the K, and you have the temperatures, 3 different temperatures. Then you find the temperature in the Kelvin at 273 and get the 1 over temperature. So it shows the steps. Part D of the experiment, it actually tells us step by step how to do the calculation. I don't think anybody goes through data sheet like I did today to show the students for 1046 how to do these calculations. If you follow the procedure, you follow the last step, it says how to do the calculation, you should be fine. I was just trying to make it easier for you. This week, this Friday is, usually I don't get many people from your class anyway, but I do get like 1 or 2 of you for the office hours. But this week, there is no school on Friday because we all have to attend a meeting college-wide. It's called Professional Development Day for us. So I'm not going to have office hours this week. You need to plot the graph, and plotting the graph, also the information is given, and it tells you how to, your plot is going to be based on L and K versus 1 over time, and I want to show you where it is. Okay, here it shows how to do the calculation. Everything that I just said is written here. So in case if you missed anything, like Crystal and Juan, since your connection was weak and you were going back and forth, it's written here. It is also recorded under the pre-lab discussions for February 16. Today is 16 or 17? 16, yes. So you will also see the calculation right here. Okay, L and K versus 1 over T, and T must be in Kelvin. For trial 5, 6, and 7, you find the slope, and from the slope, you can calculate the value for activation energy. Okay, You don't have a mini lab report, it's just this calculation for this experiment. Questions for me? Did you say no questions? Okay. I'm going to call for attendance at this point. I could still answer your questions. It's just that if after I call your name for attendance, if you have to leave, you can leave the session and start watching the video. Megan?
Here.
Thank you. Tiziana?
Here.
Juan? Juan? Saima? Crystal?
Here. Did you get me?
And who's this? Saima?
Yeah.
Saima? Okay, I got it. Robert? Thank you. Natalie?
Here.
Natalie?
Here.
Thank you. Aline? Janelle?
Here.
Caitlin? Isabella? Nia? Isabella? Nia?
Here.
Andre? So Isabella is absent? Camilla?
Here.
Kaylin?
Here.
Jonica? Neftali? Alex?
Here.
Thank you. Alana? Naveed? Daniela? Luke?
Here.
Naya? Sabrina? And Euban. Any questions? If you have any questions, you may ask at this point. If you don't have questions, thank you and have a nice day. Please read the experiment carefully, especially the parts that is asking how to do the calculation. So you don't get in trouble for the calculation.
Professor?
Yes.
I don't know if you saw it, but I sent you an email regarding, I think it was Mini Lab 2, the one that we could resubmit.
Mm-hmm.
I don't know if you saw it, but, yeah, I sent you an email. I don't know if it arrived to you, but I got points off for a question first. Yeah, I sent an email. I'm sorry.
Let me look at the email. And who's this? I'm sorry. Nia? That was Nia? Nia? Was that you? Who sent me an email regarding that?
Yeah, I got kicked out. It's Nia.
Nia, when did you send the email? I don't have an email from you.
I sent it over a week ago.
And I told you, let's look at it in the lab.
No, I didn't get a reply.
That's not possible. What did you send email with D2L?
I did.
I don't have email. I went just back to February 9th and I don't have an email from you.
I sent it the 6th, February 6th at 7:12.
Okay. I had an announcement for that. That's probably why.
But it wasn't regarding honor lock. It was the comment that you sent was that I didn't indicate bismuth on the table.
Mhm.
But I indicated it, but I didn't put BI. I spelled it out. So I'm guessing why it wasn't really visible. But I got a point off, so I just wanted to, yeah.
Let me check. That was mini lab 2, right? Week 2 mini lab?
Yes, it was.
Okay, what's your last name?
It's good.
Starts with
G.
G?
Oh.
I got
Yeah,
it.
it starts with G. Okay. I can't really enter the room right now because my Google Chrome is not responding. So I don't know if you're typing anything.
The
or
data
showing
sheet.
anything.
Okay. The data sheet. Okay, on the data sheet,
Yeah.
you have and no bismuth is present. Okay. I got it.
You saw it?
Mm-hmm.
I can't hear you. Sorry. My
Yes,
Chrome
yes.
is up.
Sorry.
Okay.
I see.
Okay. And for the pre-lab, I didn't know about equation editor or what you were talking about before, but I wanted to show my calculation, so I added two small images to show it. I don't know if I'll get points. I don't know.
Just make sure to use equation editor because that's one of the purposes and competencies for this lab to make you to be able to use the equation editor and write, show your calculation by typing it.
Okay. I'll definitely do that next time for the upcoming lab. I apologize about the images, though I didn't know.
That's okay.
But
That's okay.
thank you.
Okay.
Thank you for taking the time to speak with me. Have a good day.
Sure.
Bye-bye.
Bye. Okay. Crystal, you have a question for me?
Yes.
Tell me your question.
So experiment 2, it's not a question. I just say something. For experiment 2 during class, I keep logging off. So I know I could just go back and look at the recording.
Yes, you need to watch the recording.
Okay. And what else? It's so for like the experiment 2, the pre-lab one. So like we only supposed to like, you know, what professors in chemistry 1046 lecture taught us how to do it, right? Like we're supposed to do this by ourselves, like pre-lab questions.
The calculation also shows in the actual experiment too also.
Okay.
So if you read the equation, either or you would look at the either lecture or the experiment itself actually.
Okay. What else? Yeah, because I was looking at the pre-lab questions. I already done it, but it's like, like for A, it said determine the reaction order for NO and F2. I don't know if I said that correctly.
Okay, I think you need to watch the video for today. Let me
Okay.
stop recording so you can go ahead and watch it in like 5 minutes maybe. After